everyone's doing well. I'll go ahead and get started. It's 11 o'clock where I am in sunny Dallas, Texas. This is going to be our kind of our next series, I suppose. Those of you that are continuing on, thank you. For those of you that are new, I'd like to go through some pretty brief topics. I'll record them, throw them on YouTube so you can view them later. We'll do some questions and answers at the end. So let me get through my little spiel first, and then you can ask whatever you want. Honestly, I don't particularly care. So the last session, we kind of started from ground zero. We started from absolutely nothing and hopefully got a running model. These next couple sessions are going to be kind of building on that. Hopefully we have a running model. Now you want to run more models, right? So this idea of kind of more analysis types, optimization is something that I love, and we'll do a lot more of this series. So yeah, without further ado, we'll go ahead and get started. Since we are kicking off a new series, I will start by using the newest version. There's no reason for me to make content in anything that's kind of older. So this is the .1 release of 2022 that just came out, probably 2 or 3 weeks ago. So it's fresh. Today is modal analysis. So, normal modes, we'll do free, and then we'll kind of do a constrained modal analysis. And all of this next week is going to be linear buckling, which depends on modal analysis. So, I put some thought into what I'm doing here. Just to keep this simple and something that you can follow along with at home and show all your friends, I'm just going to build a simple rectangle. So using the geometry tools here, we'll do it. Let's go 12 by 6. Okay, and fill it in. Okay, so mesh, these are all things that we covered in the, blue. Who picked blue? That's just hard to look at. Okay, it's a very blue. Change this color real quick. I'll go ahead and mesh this, so just put a quick 2D mesh on the surface. Element size of 1 will be fine. Doesn't have to be anything perfect or fancy or great. It just has to be good enough for government work. So if I am wanting to run, just a free modal analysis, right? This is analysis I suggest everyone does, just to make sure that your model is connected appropriately. You don't have a random part flying off into who knows where. And it's so easy to do. It's like, why would you not do this, especially in OptiStruct, right? So I'm always going to focus on OptiStruct, which is Altair's solver, and it allows us to run different solution types in the same file, right? So if you are using another program that requires, a solution keyword, and you can only run that solution, it's a little hard to do. But I'm not limited by that. So if I just want a free analysis, I don't need any loads, don't need any boundary conditions, but I do need a material and a property. So that's under my model tab. I'll go ahead and create a material. We'll just call this, I won't even call it anything. I'll just leave the default name, and I'll actually leave the default units in here because those that are following along previously understand HyperWorks is unitless, and I have absolutely no idea about units. It's 12 by 6 bananas is what we made. Each of these elements is 1 banana long, and those are my material properties. I'll go ahead and make a property card for my shell. Once again, I won't particularly name it anything, but I will say that it is the banana material that we made earlier. And I'll give it a thickness. So 0.1 would be fine for this. The kind of the final step of this whole process is I need to tell the elements that they, where they belong, to which property they belong. Okay, so that's going to be this little icon at the top right of properties to be able to assign a property. So I'll select from a list that property, and I have a very simple model, so I don't have to go searching for any of this stuff. And I'll just assign it directly to all these elements. So I'll just click and drag a box and hit the play button, and now it says property 1 has been assigned directly to 72 elements, which sounds just about as dandy as we can hope for. Okay. And to be honest, right now I'm ready to run a free analysis. Well, I'm ready to, I have all of the prerequisites necessary. The last thing that I need to do is I need to define a frequency range in which over to search for, the number of modes I'd like to extract for my free, and then the load step. Okay. And for those of you following at home, a this is pretty solver specific. So what I tend to do is I tend to use the little magnifying glass up at the top right. And I know that in order to run a modal analysis in Nastran or OptiStruct, I need a EIGRL card, so EIGRL card. I'll just type that directly in there, and it will show me this. And when I select that, it will bring up the dialog necessary in order to do this. And we've changed this to a load step input. And this is kind of a departure from what we used to do in previous releases. But we are trying to be a little more agnostic, because if this is your first time running a free modal analysis and someone told you to run a free modal analysis, you'd have absolutely zero idea to look for a EIGRL card. What you would be looking for is like, modal analysis or free. So we're trying to move a little more towards an engineering realm, less towards being solver specific. But all that this card is really asking you for is a frequency range of interest. So between V1 or V2, or you don't have to do all of these. You can do a number of routes, so the number of modes you would like extracted. So my best practice, if that means anything to you, is I like to set this to 0. There are negative modes, but they're usually just in the opposite direction. So again, it's more of a mathematical thing, but I like the positive nodes. So I'm just going to say anything above 0 and give me the first 10 modes. Understanding that the first 6 modes are those kind of rigid bodies, right? So okay, so that's really all I need here. Hit close. So I have this load step input, that's the EIGRL card. And the final thing that I need to do, that I tend to just do over here in the model browser, is right click, create a load step. So this is essentially telling the solver what we are going to send to it, what I need you to collect all together before you actually run. Okay, so I'm going to call this free. I'm going to change this to normal modes. And for a free modal analysis, all I need to do is define the structure, so the referenced EIGRL card. And as I hover over some of these, I'll get a little built-in help, which is quite nice. Okay, so I'll select that load step input that I just made, and donezo. Okay, let's run this. Analyze. Yeah. That looks good. I'll just save this to my documents. I'm not going to be anything specific. Analysis. The default's optimization. If you leave it at optimization, it'll run fine. It'll just only run one iteration of an optimization, and it won't change anything. Okay. So I'll go ahead and OptiStruct. You can obviously export this as your solver deck and then run it however you like, command line in any solver that you'd like. But this is pretty low cost way for me to solve this. So the analysis is complete. I'm going to go ahead and close this. And part of today was not only setting this up, but also viewing it, right? Because what is the good of, doing all this simulation if you can't actually make a little rainbow plot and show your boss what you did? It's not good, right? So within HyperWorks, I'm just going to go ahead and split my screen up in two. So again, at the top right, I'm just going to go ahead and select this format where I'll have kind of my pre-processing on the left-hand side. But on the right-hand side, when I click on this, it's going to change over to our post environment. Okay. So I see I have some new tools up here. They're all post-related, so contours, results, free body diagrams, different types of things. Okay. And this is essentially Hyperview on the right-hand side. So Hypermesh on the pre, on the left, Hyperview on the post. I will open up this model that ran. So it was in my documents. I'm going to find my documents. H3D is our binary file, but once again, we're pretty agnostic to whatever solver. So this could be your bulk data file in your XDB file, or it could be an IMP file in your OP2 file. It doesn't particularly matter. Let's bring in the model here. Okay. And then in order to look at all of this, all of your modes are going to be listed here on the left-hand side. Okay, so left-hand side are going to list all the modes. Like I said, the first 6 are usually your rigid body modes, so those are essentially 0. You can see they're just e to the minus a pretty big number. So we'll just statistically call that 0, and really your first mode starts at 7, etc., etc. So I'll select that mode. I will go ahead and throw a little contour on this. So I'm just going to contour the eigen mode and hit apply. I'm not going to do anything crazy. One thing that I do have to do here, once again, because I don't really care about results, is I usually have to scale the deformation back quite a bit. So like 001 or something. Maybe even more than that. 0001. Okay. And now I can play a little animation and I can make it modal. And I can go flappy, 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 flappy. Right? So that's the first mode. And also change the speed at which this plays so we don't have a stroke. Excellent. That's the first mode, second mode, twisty mode, third mode, fourth mode, etc. Okay. So that's free, right? This is just if your part is in space. This is a great thing to do on large assemblies to make sure that your models just aren't flying off into infinity, right? You forgot to connect a piece and you're getting displacements on like the e to the 10th scale. That's just, something's wrong. Okay. And it took very little, effort for us to do a modal analysis. Okay. The second modal analysis that I like to do is I like to do a constrained one because that's also very applicable to what we're doing. So back here over on the left-hand side, I will just come and add one or two extra things. So I'm going to go ahead and clamp one of the edges of my plate, and then I'll run a modal analysis again with the boundary conditions engaged. So under Analyze, I have the option for boundary conditions, constraints. Let's drag a box and grab all of the nodes on the left-hand side. And I'll just constrain them to 0. Okay, that's all that this is saying. So 1, 2, 3, 4, 5, 6. It's just completely clamped, right? Not the best modeling practice, but don't judge. Don't be one of those people. So I just needed this kind of load collector to put these SPCs in. That gets made for me automatically. And I'm just going to make a new subcase. So once again, a new load step. I'm going to call this constrained modal. You can call it whatever you want. Once again, this will be a normal modes. I will again include the IGRL card that we made earlier. And then finally, I'll just put in the SPC. So I'm saying the only really difference between this one and the other one is that now I'm just going to say, well, you have to abide by this clamped kind of constraint. And we'll see how the modes change, right? So hit close. Once again, run this. These runs don't take very long. Let me change the name of this run to 39, I suppose. And hit OptiStruct, and it'll run. And then I'll do the same thing. So I'll add another window here. I guess I can do that while that's running. Nothing says efficiency like just, pushing your computer to the edge. So I just split my screen into 3 now. So I have, my free is up here. I'll put my my other results down here. I'll hit it open. I'm going to assume it's done. Go and find 39. H3, hit apply. Kind of do the same process here. So put a contour on it. Apply. And then also my deformation, like I said, if I had any knowledge about material properties, I can do this. So this is, showing subcase 1, but we need to go to the constant modal or the constrained modal. Okay, so now you'll have modes of everything, and we can, play these. So here's my flappy mode. Here's my twisty mode. Here's my bi-flappy mode, my bi-twisty mode, etc. And then it goes on and on, right? So this is the way to go. I did see a question that I will answer here, so it's recorded for history. How do I get a nice little picture out of this? Excellent question. File, screen capture. This advanced capture tool is quite nice. It's just kind of a built-in capturing tool where you can either select the full screen or select an area and then start a recording and stop a recording. And then all of your options for where it gets saved, the file format, MP4, if you wanted GIF, you can, but we'll give you MP4. You can play it on your iPhone. So all of the options are in here. This is just a fun little tool. This works in HyperWorks, HyperView. It's pretty agnostic tool. It's just under File, Screen Capture. Okay. And with that, I do hope everyone's doing well. I will stop the recording now and answer some questions if I find where we are. Stop recording.